11.91 minus 11.370 equals 540 minus 540. So we're off by a ½ inch. So how do we make up a ½ inch? You put a stroker plate on here, go up a ½ inch, boom, you're done. You take a 1/4 inch out of your stroke. Oh no, you have to take an inch out of your stroke. That'd be a lot. It ain't gonna happen. So I don't think it's an inch, so I would drop it, yeah, it'd have to be double. Yeah, you have to take an inch off your stroke. That ain't happening. So that's the less stroke than the motor's made for. So obviously they run a different height deck on the airplane motor than what this case is. So we're way the hell off. 540 is a lot. So now if we take the compression height here and shorten it by a lot, which we have a lot to work with because we were 1.6, you can easily go down to 1.2. Easy. That'll make up 225 or 425 thou right there. So that'll drop this number down to 120. You're taking a 1/4 inch out of your stroke, you go down to 4 3/8 stroke, you're in the ballpark. Now, if we take more, if we tighten up the ring stack even further, we can get a little bit more. If we run a little bit of plate underneath here and jack it up the 1/8 inch, we're golden. So there's a lot of different ways to do it. So it looks like a long stroke is going to be a problem. So we're going to have to take some material away. Next thing is, how much is this piston coming out of the bottom of the cylinder with our stroke in here? So, direct measurement, we'll figure it out. Now the other thing is I had the length at the top of the cylinder. Let's say this is the top of the cylinder right here where this steel insert in the piston is. You still have all that more distance you can go up before the ring gets to the top of the actual cylinder. So that's another 150, 100 thou more. There's our number right there. Custom piston, boom, you're there. That did it. The other thing is we can change it. We can mix and match a bunch of other dimensions and come up with what we need. We can go with a shorter connecting rod and gain a bunch of length. But the problem is the piston comes out the bottom of the hole. So now we got to figure out where the bottom of our hole is going to be. So for me, the bottom of the hole, okay, we need to go how far can we run this piston out the bottom before I get in trouble with myself? So, do you want to have it 100% inside the cylinder? I'm going to pull that whole ringland out, like that. Pull the whole damn thing out, because it doesn't matter. Stop right there. Stop right in there. What is your level of comfort on how far you come out of the motor? So if that piston was missing from here at bottom, it would look like an Evo piston. It look like an Evo piston, see? So you can pull it out quite a bit. So that much can go away. It would still run, but it'd probably knock a little bit. So obviously it'd be nice to have a little bit of that on contact. Now you got this big groove here that's lost contact, so you actually have to go almost to here to get any more material. If you went to a custom piston, that would be solid right there. You could end it at the top of that groove. Or you can put it wherever you want it to be. So for me, if I put the ring a little bit underneath the full cylinder height, and I go down to however far I want to go this direction. I'm thinking 2.2 I'm comfortable with, or 2.3 inches. So good with 2.3, I think. We know our cylinder is 6.5. So if we take off 2.3 off our 6.5, 6.5 minus 2.3 gives you the stroke you can use. 4¼ inch, 4/200. So it looks like a 4¼ stroke is kind of our limit for most everything, which is not the direction I want to go. Now if I shorten the rod, it's going to get worse. It's going to be a problem. If I move the cylinder up with a spacer plate, you're still going to have the same problem. You're pulling the cylinder out of the piston out of the cylinder. So it's not helping you. So what we're going to have to do is do a compression difference here to do it. Now I got to figure out what they had, what was their comfort level coming out the bottom of the sleeve on the airplane motor. That's what I got to figure out. So I don't know where this stock is. The other thing is I don't know how far this piston goes into the cylinder before it bottoms out. That's another problem. Now that is easy enough to figure out. You take this number right here, you zero it. Close enough. Okay, I zero my caliper to where my piston is. You just take that and go about there. And then we measure what we got. We didn't zero the mic caliper out again, did we? So we're about 3.5 inches. So that piston to be 100% in the cylinder and hit the head up there is a 3.5 inch stroke. This motor runs a 3 3/4 stroke stock. So obviously they run that piston out of the hole a good 5/16 of an inch. Because you're going to have at least a 1/16 of an inch clearance to your head up in there to clear. And then you're going to have the stroke difference. So that's going to put that thing up about right there. So they're running at least that much out of the bottom of the skirt. The sleeve here is how they're doing it. So that's about that much. Now I was figuring about right to here. Now if I do a custom piston, I can increase these lengths a little bit. I was hoping to use this stock piston, but it ain't happening. Not unless I do some serious changes. So right now we are using S&S is on their piston. They're using 1 5/8. So that was off the bottom of the ring. So this one here is 2.2 inches. 1 5/8 is way down here. That's lower than what I was doing. I was up here. I was 100th above that. So still safe, but different. Alright, so it looks like we're going to be not working with a stroker crank at all. If I run a 4 1/8 inch stroke in this motor, it's only going to be 132 cubes. So I was hoping to get at least 4.5 stroke out of it, but I'm definitely going to have to do a custom piston to get anywhere near that. If I want to use a stock piston like this that I already own, then the stroke's going to be a lot less. Or I'm going to have to run the piston way out of the sleeve and make this motor taller. So I can go over these things and figure it out. I don't know what I'm going to do yet. So obviously I'm going to go all these dimensions over. I'm going to make myself a little cheat sheet and kind of figure out where I want to run. You know, how much I want to shorten the piston, how much I want to come out of the sleeve, how close I want to get to the head. You know, the ringland here. This piston's thicker than hell. I can probably cut off a bunch off of this thing. This thing is thick. How thick is this piston? I don't know, but it's thick. So, you know how thick a piston is? You take your straight edge, you zero it, Give you a number. Go across your deck like that. Go down and get a measurement. It's about that much. You just go around like this. You do a direct reading. Your piston's that thick. Most of that piston ring is how much it is. Okay, measure this again to make sure I'm about where I want to be. Okay, so it's about 285. Oh, that's the thickness. There you go. It's 0. Pretty close to 0. So that means we're this thick. That's how thick this material is. That's pretty thick. So this is 375. You can run a piston at 180 to 200 thick. So that means I can cut 100 thou off that easily without hurting a damn thing. And I'm still over a 1/4 inch thick. If I want to go down to 200 thou thick, I can cut another 75 out of that. So 175 material can come off of this thing to be 200 thick. So 175 thou would be right about there. Just above the height of that steel insert. I wouldn't want to run it that thin on that steel insert. I want to have some material there. That's a little closer than I want to be. I probably want to have at least 80 thou or so, or something above that. I don't know. I'd have to think about it. Like I said, the piston's thin because that steel insert goes all the way across, so you don't have a lot of material. It can fold up on you. And under cylinder pressure, it can actually lift up on you, and then the whole ring insert would get loose in there, and then everything goes to hell real quick. So to be safe, you probably need 100 thou right there, but we don't have 100 thou. Can't cut that much if we did that. It's 225. We cut 125 off of this, so we're 50 thou short of what we could run. So the piston dome would be 250 thick instead of 375. We got 100 thou here, which is I'm fine with. So I can cut that right off. I can cut the 125 I mean right off the top. Now 125 off of our 540 number puts us at 410. And remember, we shorten our piston. We can make a custom piston and come up with that extra dimension too. But, so I'm still 410 short. So if I made the piston really short, I could pop it out of the cylinder. Right here. This thing pop out about that far out, like that. You could run the motor with a 4 1/4 stroke in it. Let's see, we were at 4 5/8 stroke, that's what we're doing. You could run that thing way out like that. It would work. That doesn't leave much. I've actually run my race bike this far out with a 5-inch stroke, half a wrist pin. It is hard on pistons. They don't last long, especially at 7,000 RPM. So. Alright, so I don't know, I gotta figure out what I want to do. If I use this piston, I'm definitely going to cut an 1/8 inch off this dome. I'll guarantee you that. It's coming off. So I just got to figure out all these other dimensions. So now I know I got a problem with stroke. I already thought I had a problem. Now I know I have a problem. So it's going to be a struggle to get the 4 1/4 stroke in this thing. So, which is way less than I want to run, but if that's all I get, that's all I get. I didn't make the cylinder. The cylinder's too short. If the sleeve was long like it should be, it'd be no problem. The damn sleeve is 1/2 inch too short. Plain and simple. They didn't make this long enough here. Ultima motor, that damn thing's way down here. It's way longer than this. Now look how deep the cylinder spigot is in this case here. See how thick that is right in here? Look how thick that is. You know, all the way around, that thing is huge. You know, they were made this motor to be, you know, the sleeve would go down to this. It's cut away to clear this. It goes behind. It goes around this damn thing. You know, that sleeve goes down there like this far. See the difference? Look at that. That's over a ½ inch difference. So if this sleeve was longer, we wouldn't have these problems. But they made it short, so you can't reinvent the wheel. You know, I could press the sleeve into this thing and drop my bore down and make it work. You know, I could take a, you can make the sleeve a 1/16 wall. You know, with good sleeve material, you can make it a 1/16 wall. You drop that down from 4.4 down to a, that'd be 125 less than 4.4, so that'd be 1/300. It's about 1 5/16 bore. That's what you make the motor into, but I don't want to go smaller. You're going to either lose the bore or you're going to lose the stroke. Either way, it's going to get smaller, so it's easier just to lose the stroke. So anyway, that's where I'm at. So I got to determine what I can do to get my comfort zone back here a little bit. I was trying to avoid doing a whole custom piston, but it's to get any stroke in this motor at all, we got to do a custom piston. I don't see any way of getting around it without doing it. The numbers don't lie. It is what it is. So, I don't know. Anyway, that's what we're going to figure out. Lots of things to figure out, as usual. That's it for tonight.